Okay, welcome today. Let's start by checking our assignment numbers 1 through 4 on page 11. Okay, so take out your notebooks, give those a check. Make sure you pause this whenever you need to check answers or look something up or calculate today or something. Anything you need, just feel free to pause this. Okay, so there's number 1 and 2 through 4. Okay, today we're going to express a product in exponential and standard form and write an equation for exponential relationship. Good luck, this is going to be fun. All right, first, exponential form. We talked about exponential form a little bit yesterday. Exponential form is simply writing it, a whole bunch of numbers being multiplied as an exponent. So, for example, this is exponential form right there. Nothing more, nothing less. Okay, so exponential form, pretty simple. Terms you need to know, write these down, please. The 2 down here is called the base. And up above, the 5, the small number up there, is the exponent. They are not the big number and little number. Do not call them the big number and little number. These are the base and the exponent. You'll be expected to know those terms. So please make sure you do know those. Okay, now 2 to the 5th can be simplified to be 32. 32 is what we call standard form. Standard form means just calculate the 2 to the 5th out or whatever exponent it is. So standard form also very simple. Just go through the calculation for it. So let's try some problems here. So first thing I want you to do is take a minute and write down what you think each of these are in exponential form. That means just using exponents, remember. So go ahead and give those a try. All right, the first one you should have had 2 to the 3rd. The next one was 5 to the 4th. And the last one was 1.5 to the 1, 2, 3, 4, 5, 6, 7th power. And we can put that in parentheses if you like, just to clean it up a little bit, make it nice and neat and clean. Okay, so that would be exponential form. Now, try to write these in standard form. Okay, in standard form, the 2 to the 7th is 128. The 3 to the 3rd is 27. And the 4.2 cubed is 74.088. But if you said 74.1, yes, you're a winner today. Good job. All right, open your books to 1.2. 1.2, please. All right, today we will begin the saga of the kingdom of Monteric. One day, oh, you can wear the crown if you're reading this along too. So put on a Burger King crown. It's fun. Everyone loves a crown. One day, in the ancient kingdom of Monteric, a peasant saved the life of the king's daughter. The king was so grateful, he told the peasant she could have any reward she desired. The peasant, who was also the kingdom's chess champion, made an unusual request. This is my best peasant voice. I would like you to place 1 ruba on the first square of my chessboard, 2 rubas on the second square, 4 on the third square, and 4 on the fourth square, or 8 on the fourth square, and so on until you have covered all 64 squares. Each square should have twice as many rubas as the previous square. The king replied, "Ah, ha, ha, ha! Rubas are the least valuable coin in the kingdom. Surely you could think of a better reward." But the peasant insisted, so the king agreed to her request. Did the peasant make the wise choice? Discuss with a neighbor. See what you think. Did they make the wise choice here? The peasant. Is this a great deal or not? Okay, well, let's find out. First, write down in your notebook this table. So go ahead and take a minute. We'll go through, yeah, probably about 10 rubas or so, or 10 squares, excuse me. Okay, after you wrote that down, okay, so let's review the problem here. It said one ruba on the first square, two on the second, four on the third, eight on the fourth. Okay, so let's take a picture of this here. So we have one ruba here on the first square. We have two rubas on the next square. We have four rubas. Here's four rubas. One, two, three, four rubas on the third square. And yes, that's eight strong rubas. One, two, three, four, five, six, seven, eight rubas there. And I even went to the next square here. We have 16 rubas. 5, 10, 15, 16 up there. So we have 16 rubas on the fifth square. So let's write these down. Number of rubas. The number of rubas on square one was 1. Number of rubas on the next square was 2. On the third square was 4. On the fourth square was 8. And I actually took it to the fifth square, which was 16. Now you take it to the next 5 squares here. Take it through square 10. Go ahead and write those in. Okay, hopefully you said 32, 64, 128, 256, and 512 rubas on square 10. Now, the operation part. What's actually happening? What do you see happening here? Discuss with the neighbor. You have 10 seconds to tell us what you think is happening. Okay, you should have said, hey, it's doubling. We're going 2, 4, 8, 16, 32, 64, 128, 256, and 512. That's awesome, doubling. So what operation is going on? Now we're going to do this similar to the amazing Chen yesterday. We had one ruba on square 1. And we're doubling it, so we're going to take that times 2. And then we're going to take the 1 times 2 and we're going to multiply by 2. And then we're going to take the 1 times 2 times 2 from square 3 and we're going to multiply by 2. That's how we get the 8 right here. And then we're going to take the 1 times 2 by 2 by 2. And wait, we got to double that. Okay? So now, how can we write this? I don't want to write this out anymore. How can we write it in a simpler form? So see if you can write down how we can write this in a simpler form in the last column. Okay, you should have said, well, this is 2 to the first power. This is 2 to the second. This is 2 to the third. 2 to the fourth, because we have 4 2's right there. So 2 to the fifth, 2 to the sixth, 2 to the seventh, 2 to the eighth, 2 to the ninth, and 2 to the 10th. Well, we're not doing that far, so 2 to the ninth. Okay. So we get carried away playing with rubas all the time. So here's a shorter version of this same thing. And we said that we double from one to the next. Now we want to come up with an equation for it. Now I'm going to compare this to the amazing Chen from yesterday. Now the amazing Chen had this nice board here. And what we noticed from the amazing Chen was the number of cuts matched the exponent on the operation. So 0 cuts, 0 for the exponent. 2 cuts was 2 for the exponent. 4 cuts was 4 for the exponent. And because they matched each other, then we could say the equation is y equals 2 to the x. Okay? Or y equals 2 to the c. C being the number of cuts. So whatever the number of cuts was, so let's say we were on cut number 12, it would be cut 12 would be 2 to the 12th power. Okay? Now, see how this Chen's board matches with the peasant's plan. Is it the same? Discuss with a neighbor. Come back in 30 seconds. Is it the same? Okay, and what you should have noticed is it's not the same. It's off by a little bit. It's changed. Instead of being cut 0 being with an exponent of 0 or cut 1 being with an exponent of 1, we now have square 1 with an exponent of 0. Huh. That's different. And we have square 3 with an exponent of 2. So how do you think we could write this a little bit different? How can our equation match what's going on the board? Go ahead and give it a try. See if you can come up with the answer. Discuss with a neighbor. Okay? Hopefully, this is a little more difficult, but maybe you figured it out. Okay? So if we have our equation here, our base stays the same. The 2 is still there. It shows up on every part of the problem, so the base stays the same. So all we have to do is match the square with the operation. And to do that, we're going to take the square, I'm just going to say n, and we have to subtract 1 to get to the operation. Here's what I mean, if you didn't catch on. If we're on square 3, okay, square 3, that's 2 to the 3 minus 1 because we're on square 3. But 3 minus 1 is 2. Well, on square 3, notice we have 2 to the second power. Holy cow. Yeah, that's right. So on square 5, we have 2 to the 5 minus 1 because square 5, that's that number right here. It's going in for n. Just fill in the blanks. So that's actually 2 to the 4th power. Well, let's check it out. 2 to the 4th. Hey, that's 2 to the 4th power. So our equation is 2 to the n minus 1. Oh, wow. That's kind of cool. All right. Awesome. Okay, now let's go back to our table, and I'd like you to give this a try. You can either put this in your notebook, or if you're in the class, we can try this on the board. We want to graph our 10 squares and see if you can put them on the board here. So go ahead and take a second and give that a try. Okay, your graph should have looked like this. A little different graph than we've seen before. It kind of has a curve similar to inverse, but notice it has a y-intercept and it's going up. And it goes up very fast after a while. This thing's like a rocket ship. Now it's going to keep on doubling and doubling and increasing faster and faster and faster and faster. This is amazing. This could be this is going to make the peasant absolutely rich. Awesome. So we already talked about the equation. Now they use square n and Rubas r. So Rubas equals 2 to the n minus 1. That's what we said what our equation was for this problem. Now, how does it show up in the graph? Well, the pattern that we talked about doubling every time in the graph, well, obviously look at the graph. It's doubling every time. And once that gets to a certain point, holy cow, that thing's taken off. Now, how does it show up in the equation? Well, the doubling is right there in our equation. That's actually our base. And remember that that's the term we need to know, base. And that's how it shows up in this problem. Okay, now, 2 to the 30 Rubas. Which square will have that? Now, you have to remember, we had our equation 2 to the n minus 1, where n was the square number. So we have to convert that to Rubas, which is 2 to the 30th. Now, discuss with a neighbor. See if you can figure out, now n is the square number. N is the square number. So what square number is going to make that into a 30 for an exponent? Tough problem. Discuss with a neighbor. I'm hoping you came up with 31, because if we have 31 minus 1, well, that 31 minus 1 becomes 2 to the 30th. So the 31st square creates 2 to the 30th Rubas. That's a lot of Rubas. All right, now, the first square on which the king will place at least 1,000,000 rubas. Now, this is a little bit of guess and check. You kind of have to plug in some numbers into your exponent and maybe write some down along the way. So give it a try. It takes a few times to get through this a little bit. So give it a try. Now, what you should have found was that on square 21, so that would be 2 to the 21 minus 1. That's square 21. Square 21. Okay? That creates 2 to the 20th power. 2 to the 20th power was, oh, I got to get this right, 1,048,576 rubas. Now, on square 20, square 20. So that would be 2 to the 20th minus 1 because that's where we're putting the 20 goes in for that n. Well, what exponent do we create from that? That's 2 to the 19th power. Now, if you put 2 to the 19th in your calculator, you should have 500, oh, what is this now? 524,288 rubas. That's a lot of rubas too. But just notice, when we get from square 20, which is 500,000 rubas, to square 21, which is 1,000,000 rubas, holy cow! We're only on square 21, and the peasant has 1,000,000 rubas. That's unbelievable. We have to get to square 64. This is a lot of coins. Who's got all the bags, the money bags for this? Where is she going to keep it all? I don't know. What's going to happen next? Is the kingdom going to go bankrupt? Is the peasant going to be rich and retire and buy the kingdom herself? Will the peasant find true love with the frog in the forest? That's weird. Because is it really a frog or was it a prince? I don't know. Is that a different fairy tale? I'm confused. Okay. All right. So we will continue the saga of the kingdom of Monteric on another day. Hopefully we learn something about exponential growth.